Alright, another physics video. Yeah, I don't know. I shouldn't bother dignifying some of these videos with a response. Rudethloday has made two videos. Very insulting. High school physics for inmendum and the ignorance of inmendum. You know, and they're just more ad hominem attacks. No direct quotes, no rational, relevant arguments to any of the physics I'm talking about. So just more of the same old crap from crappy people, okay? This is another theory I have, that humans basically suck. And certainly, yeah, a lot of arguments can be made about what intellectuals are doing to the world with their a little knowledge is a dangerous thing. Yeah, well, that's quite evident with people like this. So anyway, so I'm also going to play a little bit of this general relativity and introduction 2 of 2, which is going through some of the thought experiments that apparently got Einstein thinking about this curved space crap. Yeah, it's just, this is no point. I should read a comment too. Damn, there's so much to do. Yeah, somebody left a comment about you know, why, you know, because I made the comment, why did Einstein bother, why did Newton bother talking about velocities in all circumstances? I mean, we have no access to all circumstances. We have no access to a you know, 80% of the speed of light spaceship. And why would somebody speculate that at an 80 mile an hour, I mean 80% of the speed of light spaceship, that physics is going to be the same? Why would somebody make this statement? You know, presuming they know what matter is, and presuming they know how durable matter is. That matter can go 80% of the speed of light, and it isn't going to change any. I mean, it just seems like, why did they go? Yeah, I'm just saying it. Why bother doing that? Why play this game with this relativity word when really all you're talking about is special relativity, or circumstances that you can experiment on? Ugh, fuck. You know, yes, it doesn't make any difference. Small differences doesn't make a difference, but big differences make a difference. Gee. I have to write that down somewhere? Little differences don't make a difference. Big differences make a difference. Yeah, that should be one of the laws. Fuck. Anyway. Alright, so I'll just go down the list. Okay, so first, Rudethloday just complained because I'm using the word angular momentum. And then he says, well, angular momentum has to go blah, 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 through angles. Well, yeah, that's my whole point, is that every zillisecond of your existence, your angular momentum is being changed. Every zillisecond, the direction of the stuff inside of you is being altered. Every tiniest plank of time, stuff is having its direction changed. Kind of think about like the moon. If you put the moon in fast, if we just did the moon in fast motion, you know, going around and around and around, at any given release point, it would have a different angular momentum. It would go in a different direction in space. So all the time, the moon's having its angular momentum changed. All the time. So yeah, I think it's sort of important, and I think it's really important in a context where people don't understand that stuff, light especially, moves based on a pitch angle. And it goes based on that until something changes its pitch angle. Shit. Anyway, alright, so if you're describing, and it should use angular, okay, well anyway, it's a rotate, well anyway, so yeah, I don't know, like I said, so this just seems to be some sort of technical argument. So if I use pitch, that would be okay. I just don't see any point why I have to change my language. You either understand what I'm saying or you don't understand it. I mean, the whole word angular momentum is, I'm only using it to concede to physics and its need to use certain precise language. But I just don't know how else I describe the fact that something has a momentum in a direction, but except to say angular momentum. It's just not plain momentum, it's angular momentum. It's moving in a direction. How else do I say it's moving in a direction, a specific fucking direction? Alright, So then to give me, I challenge people to give me an example of energy that doesn't involve photons, the exchange of photons, and he brings up gluons, like somehow he knows what gluons are doing. No, I don't think you do. So that doesn't go anywhere. Causing movement in the system. So energy equals work equals movement, which is exactly my argument. But more specifically, what it equals is change. If you're going to say you energize the system, you have to change a system. So if there are a bunch of cue balls moving on a table in a frictionless environment, and I throw another cue ball in, right, another pool ball, and that ball comes back out at me at exactly the same velocity, have I changed the system? It's energy? No. I've changed angular momentum. I've changed how the things will bounce around, but the same amount of energy is in the system. I put in energy, I took out the energy is neutral. And that's obviously what's happening when I'm saying photon interacts with photon. There is no energy exchange. The only thing exchanged is angular momentum of the light. The light's direction is changed. I don't know how else to say it. If there's some way I'm supposed to say when light changes direction besides calling it angular momentum, go ahead, tell me what the word is for it and I'll use that phrase. Okay, tell me what the phrase is for when light changes direction. Angular direction? But I mean, obviously I'm saying light has momentum in the sense that light is energy, so I think we better use the word momentum for light because light is energy. Photons are energy. Alright, so anyways, it's just a waste of time. Alright, then regarding Feynman again, he brought Feynman again, and he didn't defend it. So again, what's explain to me, what do you want me to tell you? Okay, I'm trying to explain to you that when you have velocity in a direction, okay, what's happening is the net balance of photons in your body are now pointing in a direction. So there's more of them pointing in the direction you're moving. And I pointed out that in those exchanges there'll be no change in angular momentum. If two pool balls in a frictionless environment fly into each other at zero angular displacement right into each other, they will effectively not change the system at all. They'll go right through each other theoretically, and there'll be no net change, no movement, no change in movement, no change in anything. A ball will go out that way and a ball will go that way, and that's it. It'll be entirely neutral as an event. It'll be a non-event essentially. And the whole point is that in the circumstance where you're moving against gravity, any photons that meet photons will be a neutral event. So essentially, it's all about time, okay? And so the amount of time your photons are in a position. So I'll give you an equation. Maybe this should be my first equation. That when you have velocity, what's changing is the amount of time your mass is in a condition where it can exchange angular momentum. So the amount of time where angular momentum can be exchanged is reducing as you're increasing velocity towards something. It's obviously all directional. So again, this word angular is incredibly important because energy has mass. It has mass in a direction only, and that's the whole point here. Is it's all directional. So when it's in the form of matter, the whole point is that the energy is trapped in a circumstance where it's unidirectional, and that's what we're calling mass, because we've taken the mass of the energy and made it unidirectional. But as soon as it's released, as soon as it's free to go, then all of that mass is now directional. And it's 100% where it's heading, and it's 0% everywhere else. People get that. But this is a percent ratio again. It's just that simple, that when you're moving, the percentage of your substance, okay, that can interact and exchange angular momentum is reducing by percentage. Jeez. Okay. To create heat, you must create more movement. So that's back to my argument. If the pool balls are already moving and I throw another moving pool ball in, I take it out with exactly the same amount of energy, I haven't changed the energy of the system unless the system, some of the pool balls break or in some other way energy can be made. But the whole point is, when you're talking about photons, you can't exchange heat because photons are heat. So if you're not putting more photons in, or in some way you're not releasing photons to cause trouble, there's absolutely no way you can put more energy in. If you take a photon in and take a photon out, you're not going to be able to create energy in a system. You have to convert it. So even when they're talking about redshift, it's just so irritating. You know, when the atmosphere converts, you know, light and it starts separating, it takes the ultraviolet light, knocks it into infrared light. It's taking photons, it's releasing photons, it's less photons. It's an energy transfer. It heats the atmosphere and it creates this other form of light. So I mean, it's just those are changes to the system that, you know, something goes in and only this much comes out, or it comes out in some other form. Anyway, how else to put this? Yeah, well, I want to get back to the whole redshift because it doesn't make any sense anyway. It has to happen at the source or it has to happen at the receiver. There is no redshift in space. Either your eye is either red shifting or blue shifting, or the source blue shifted or red shifted. But there's no, you can't fix it in between, because that requires you to either add photons or subtract photons. So unless you show the interaction that added or subtracted, you can't do it. Alright. Gravity and light, which creates another circumstance I was thinking about. I mean, if light's getting bent by gravity, then you'd have to speculate that when the light leaves the sun, it's in an intensely heavy gravitational circumstance. So why doesn't it get bent or shifted as it tries to leave the sun's gravity? If it's going to get bent by a gravity well, why isn't it going to get distorted by being produced in high gravity? And it's not. Alright, just a curious question. But anyway, so the real important thing is I have to come up with a word for this idea of something's kinetic potential. And, you know, it's even like when you're leaving Earth, you know, you're escaping gravity. What are you doing? Well, what you're basically doing is your acceleration, through acceleration, you're basically changing your photons so they are zero angular momentum to the gravity you're trying to overcome. And that's really the game. The game is all about how many of your photons need or can have their angular momentum changed. Directionality. It's a gyroscope, and the gyroscope is getting bombarded. What makes a gyroscope work is the very same force. Okay, it's getting hit, and the pressure is what keeps it at a correct angle. And the same kind of gyroscopic action is happening inside your atomic structure. That's what these stupid fucking electrons are doing. They're creating a gyroscopic disposition, and just like a gyroscope, they will stay exactly in that position until some force moves them. Just like a gyroscope in space will stay where it is until some gravity or some other thing affects it. Alright, so then he said the inverse square law, Newton's inverse square law, was proven wrong, that it's wrong. Now, we all know that this idea that this thumb gets smaller with distance can't be wrong, right? Okay, we can see it happen. It's quite obvious. We know that the problem with Newton's calculations, okay, now I'm not certain of this as being the only flaw in his calculations, but we know one certain flaw, for certain a flaw in Newton's calculations was the fact that they didn't account for the speed of light. So when they observed Pluto in a position and they wrote it down on a piece of paper to do their gravity calculations, they weren't getting the correct position for Pluto. They had the past position for Pluto, not the present position for Pluto. So because they didn't understand the speed of light was slower than they thought, okay, they thought it was instantaneous, they had their positions wrong. Now if you redid their observational data to match the fact that their observations are 15 to, are 1 to 15 minutes off, then maybe Mercury gets fixed, right? I don't know by how much percentage, but maybe that'll fix it. So let's go find out, right? And then like I said, the whole dynamics of trying to account for all the nuances of all the complex gravity, right? That's what we're talking about. When you're talking about Mercury's orbit, you're talking about the influence of all the other planets, plus the influence of it being right next to the sun, which is producing a ton of photons, which also have to be accounted for, I would imagine. And know what he's saying? He's saying the inverse square law is wrong because of what? A few thousand meters of inaccuracy in calculating Mercury's orbit. So because Newton made a few thousand meter miscalculation, a prediction of Mercury's orbit, he's going to say it's not correct. Inverse square isn't the correct logic. I mean, obviously I think we can know that now it probably has to do with how technical you can get, and that there's a room for error. Yeah, it's within the margin of error of a correct theory. But that's his, he's going to sit there and say, I'm arrogant and obnoxious. Look at the arrogance of him, disqualifying the inverse square rule for an idiotic, lack of precision. Okay, anyway. So change the observed time, so that's enough of that one. Okay, so let's just play the end of Rudethloday, and then we'll be done with Rudethloday, just because I found this. So he mixes both a philosophy critique and the physics in this video, which was just a waste of people's time, I believe. Certainly a waste of my time. But again, no real arguments, no quoted arguments. Just this obnoxious detailing of a claim against my integrity. When I say that I have never used the word objective to relate to objects, never in my entire life has the word objective had any association with the word object. Ever in my existence. He's saying that's not a valid claim. I can't make that claim. He's going to say I'm a liar, that I'm really using the word object all the time when I'm talking philosophy. In all my philosophy videos, I'm sure you'll find lots of them where I'm talking about objects. I'm always talking about objects. No, I think that's Professor Anton. Professor Anton's the one always picking up objects and saying, look, this object. Yeah, no, I'm not doing that. So whatever, I mean, this is just stupid. I mean, quite obviously there's a perfectly valid definition in the dictionary of the word objective, which has to do with perspective, which has to do with point of view. I'm talking about an objective point of view. When I say objective reality, that means the objectively pointed view of reality. One not biased and one not ignorant. Two components. As little bias as possible and as little ignorance as possible, and then you're obtaining an objective perspective. Whether you can have a completely objective perspective, I would argue, okay, maybe that's not possible because we're not supercomputers and all that kind of crap, but do we know enough? Yes, that's my conclusion. Way more than enough. But anyway, but you wouldn't know it listening to these assholes, that's for sure. Oh, back to the halfway. I just want to play the ending of this. It was just preposterously rude.
And in Mendham makes inaccurate statements followed by inaccurate statements compounded upon gross ignorances continually.
Yeah, too bad you can't quote any of them. So yeah, you're lame and you suck. And if you do quote them, they'll be out of context, because that's your typical standard, right? You'll just take clips out of different videos and then say, I'm saying something different, or I'm saying something deceptive. No, you just take them out of context, quote mine, and distort, because that's all you have is distortion. All you have is a straw man argument, and so you have to create a straw man. And it's just offensive. would you think you have a right to do that? Because you're a liar and a cheater. Yes, that's simple. And I'm going to show you now an example of a, I like this guy. This is some sort of English guy. I've heard of him in different videos, and yeah, he explains stuff, and that's really great. I love people doing educational videos. But man, this was just so, this is one of those like, oh God, this is so obvious. These guys are just talking up the religion. So anyway.
Starts out here. But as it travels across, the rocket has moved forward.
Okay, so this is the Einstein thing, right? So you're moving in a rocket g. I wish they would say like 80% the speed of light or some sort of number, but they just call it g. And you're going to shoot a little photon across here. Now he said light beam, right? But it's not going to be a beam of light. So beams take time. So then you have to do the time interval thing, and you have to move your gun as you make your beam to do beaming accurately. But anyway, let's just play along.
And so now, by the time it gets here, it's at this point in the rocket.
So he's pointing out that so as the rocket, so you shoot out your photon, right? And the rocket moves, and so now your photon is halfway down. Well, I mean, I think he wanted to go quarter, but he went a little too far. And then he'll draw a third rocket with it on the floor. And now he'll say, look what we see. Well, obviously, we're not going to see any of this shit.
And by the time it gets to the other side, it's here. So what is actually happening? The light is, of course, going in a straight line. But because the rocket is going forwards, it appears that the light is actually bending downwards. So the net effect to an observer would be
yeah, that the
light starts here, it's then there, and it's then there. So in other words, it's bent, it's gone down in a certain sort of...
So what? So you see this part? It's gone down in sort of a... Oh, it's not really a circle, is it? No, it's an angle. Okay, and the angle is completely dependent on the velocity of the floor. It has absolutely nothing to do with the light, and you would never perceive it this way, right? As you would never be able to see the photon. So this is all just preposterous. But I mean, the funniest part is the fact that he took a straight line and tried to turn it into a bent line, into a curve, when it's obviously not a curve. I mean, if you did a whole bunch of these little dots, the dots would always end up being a straight line based on the even velocity of the elevator thing or the rocket. So as long as the rocket is accelerating evenly, this line is going to be an angle. It's not going to be a curve. So, I mean, he's using this as an example of how Einstein got to curve space. Well, that doesn't look like a curve, buddy. That looks like a diffraction.
Bendy circle.
Bendy, he
as
calls
a consequence.
it. so it's a bendy circle. So he just called a straight line a bendy circle. I mean, it does sound like these guys are just trying too fucking hard. Okay? They're just trying too hard to make this nonsense sense. And again, who couldn't... Look, I mean, all you have to do with some of these elevator experiments is to take your little gun, your little photon producer, and just make a hole in the elevator and say the gun is out here in free space. And then how are you going to explain any of this effects that you're saying is taking place? Well, you're not going to be able to explain them because you're not going to be able to change anything or do anything. The light's going to go straight the fuck across. That's all it's going to do, and you can hit it with a tennis racket if you want to. But there's, I mean, really, are you people that confused that if I swing a tennis racket at a tennis ball, I'm going to hit the tennis ball? I mean, is that a surprise? Is that miraculous physics? Do I need to bend space to defend the theory that if you move the tennis racket at the ball, that you're going to hit the ball? Fuck. Sooner than you're going to hit it if you leave the tennis racket back here, or if you swing the tennis racket back here. I mean, come on. These aren't thought experiments. These, a 10-year-old could say, "Oh, I get it. Yeah, the thing goes across, but the floor is moving, so yeah, the floor crashes into the ball like a tennis racket." Yeah, a 10-year-old could do that. So this is a pretty lame way to defend general relativity, in my opinion. But his other experiment is even worse, but I'll go into that one another day, I think. These are all fun to play with. I mean, like I said, even this idea of the observer seeing the photon, watching the photon go across, and watching the photon crash into the floor. When obviously the observer would just say, look, the elevator's moving. I mean, the rocket's moving. The rocket just moved right into the light. There's a beam of light. I have a rocket down here. I shoot the rocket at the beam of light. Yes, there's going to be some point where I'm going to hit the beam of light with the rocket. Yes, that'll happen. First, the top of the rocket will hit the beam of the light, and then the bottom of the rocket will hit the beam of the light. Yeah, I can figure that out. Fuck. So anyway, this shit is just so, I mean, they got so much wrong. There's just, you know, I don't, you know, this is, I'm sorry, but I mean, physics is getting, I'm just amazed at all these. I mean, I used to be impressed by physicists, and now I'm like, holy fucking shit. These guys are imbeciles. I mean, scientists are just, I mean, I'm amazed. I'm just surprised that, you know, it's like Dawkins not being able to figure out that animals feel. You know, somebody had to explain that to him. You're just like, what? Somebody has to explain to you that animals have the, you know, mammals have sentient brains and that have emotional experiences, not unlike our own? Boy, you should be maybe a little troubled by the fact that we're letting them getting destroyed, killed, and harmed every day, but not, you know, without doing a damn thing about it at all, not even thinking about it. Gee, I mean, this is. I don't know. So anyway. You know, I guess like I said, I do have something to work with here in terms of change, this kinetic thing, so maybe I can write up some little formulas, you know, using my own little gibberish language, and that'll be fun, so we can add some math, but you really don't need to get it. So, you know, what I mean, I think I've explained it. I've explained it again, and then I'll explain it again different ways, but photons. Everything's made out of photons. Photons are already moving. Yeah, and what you do is change where they're moving, but that's all you can do. And that's all the entire universe is doing. It's just a bunch of photons banging into photons and changing the direction of the photons. That's all that's happening. That's why energy cannot be created or destroyed. It's because you can't destroy the photons. You can just change where they're going. And that's it. The entire universe is made out of those little things, just banging into other little things. That's it. Okay. Till next time.